Hey guys, Jacob Howard here, and welcome to this video where we're going to talk about the propellers, or props for short, on your drone. Props are probably one of the most underrated and underthought of part of the drone, even though they are one of the most important. A bad or misused prop can drop your drone from the sky, give you shaky footage, drain your battery, or fry your motors. It is very important to have the right props for your drone, and in this video we will cover what you need to look for and why each part matters. Props for drones come in many shapes, sizes, and materials. They can range from 2-inch props with 2 blades to 7-inch props with 3 blades. The two components of a prop are its hub and blade. The hub is the center part here that mounts to the motor of your drone, and the blade is the part that protrudes out and performs the rest of the work. No matter the prop's size, shape, or material though, its primary function is to provide the drone with its thrust or lift. On drones, you must have both clockwise and counterclockwise props. Like the tail rotor on a helicopter that counteracts the spinning force of the main rotor, the clockwise and counterclockwise directions on a drone counteract each other to keep the drone flying straight and level. On a drone, the props spin clockwise and counterclockwise and act like something called an airfoil. An airfoil creates areas of low air pressure above it and areas of high air pressure below it. This allows the prop to move away from the high pressure areas into the low pressure areas, creating thrust. Depending on the specifications of the prop, usually the faster they spin, the more thrust is created, propelling the drone at higher speeds. The prop literally controls what your drone is capable of in the sky. So please, again, do not underestimate or underappreciate the importance of your prop. You will notice when looking for a drone prop, you will see some numbers accompanying each one. This usually looks something like this, with Y representing each number. Each of these numbers reference a particular specification of the prop. For example, the first number is the size of the prop, in this case 5 inches. The second number is the pitch of the prop, like 5.3. And the last number is how many blades it has, like 3. This is done to help you identify your prop as quickly as possible. Let's dive into the various parts of the prop so we can see how they work together to create the desired outcome for your drone. Size. Prop size is the first thing you have to consider when looking at what props you need to get. If your drone frame only allows for 5-inch props, then it will do you no good buying a 6-inch prop. But you can have some variation within the props you do get, and understanding how the size of the prop affects your drone will be very important. The size of your prop will directly affect everything from thrust, responsiveness, and how your drone grips and controls itself in the air. For example, a larger prop will generate more thrust and have better control in the air since it has a larger surface area, and will respond better to direction changes. It also allows for dives and throttle drops to feel smoother, as the drone will have more air resistance coming back down to earth. Smaller props, on the other hand, will respond faster to inputs since they have less resistance and are more efficient at accelerating. Smaller props will allow your drone to more easily change altitude, which can be a good thing if you are racing through obstacles or race courses. Your prop size should be matched to the rest of your drone. If you put a small prop on a larger drone meant for 6 or 7-inch props, it will generate little thrust and result in your motor spinning at high RPMs and drawing much more power from the battery. Similarly, if you put a large prop on a small drone, you will create little thrust and cause other issues, such as overheating and too much power draw from the battery. Make a big mistake here and you could even damage a motor or other critical parts. Blade configuration. Blade configuration refers to how many blades are attached to the hub of each prop. Props can have several blades on them, but the most popular ones have either 2 or 3 blades, also called bi-blades or tri-blades, respectively. Adding a blade to a prop is kind of a workaround to other challenges in aerodynamics. Increasing the size of a prop creates more benefits at a lower cost than adding another blade. However, since drones have become so small, increasing the size of the prop is not an option, so adding a blade is the next best option to achieve higher thrust and control in the air. You will sacrifice some of the reaction time and more of your battery, as it will consume more power. Tri-blades are the most common prop used for freestyle droning, but several racers use bi-blades since they offer faster reaction times and are more efficient. These are usually utilized on ultra-lightweight drones that do not require as much of the thrust that a tri-blade will give. For the most common drones and uses, a tri-blade will be what you want to go with, as they provide the best balance between the most important aspects of flying. This isn't to say that 4 or even 5-blade props don't have their use, just not what most people will use them for. They accommodate very specific flying styles and expertise. One blade configuration called 3D props even allows you to fly upside down, as the blades will reverse direction and provide thrust in the opposite direction. I wouldn't recommend these props for a beginner though. Pitch. Pitch is the angle of each of the blades on the prop. When a revolution is put on a prop, the pitch determines how far it will move forward. A prop with higher pitch will look like this and usually look taller. A prop with lower pitch will look like this and usually look shorter. To illustrate, this prop here has a pitch of 5.3 inches. That means in a perfect world testing scenario, it would move 5.3 inches forward every revolution. A prop with a 3-inch pitch would then move 3 inches every revolution, so on and so forth. Now, you can probably see right away that a higher pitch prop is going to give you more speed, and you'd be correct, but it sacrifices other things. A high-pitch prop gives you more speed and thrust, but less low-end torque. Imagine if you had your bike set to a high gear. It is great for speed, but not as good at giving that extra push on difficult terrain or quick turns. High-pitch props also respond to inputs slower and use more of your battery power. Low pitch props sacrifice some speed and thrust to have that low end torque, like switching your bike to a low gear to get that extra power and control. Low pitch props will also respond quicker and be able to make tighter turns and movements. So if you plan on doing most of your flying in wide open spaces with powerful motors and something like a 5-inch drone, then you will want something with a higher pitch, like 4-inch or 4.5-inch. If you plan on flying through tight obstacles or in confined spaces, you will want to go with something closer to 2.5 or 3-inch pitch. Material. In the early days of RC aircraft, props were carved out of wood. As technology progressed, so did the materials and designs for props. It went from wooden props to an array of carbon or fiberglass reinforced plastic, carbon fiber props, and polycarbonate props, and mixes of nylon carbon composite props. Each of these different props have their benefits, but the main things to think about are how flexible or rigid the props are. A prop that is completely rigid is going to be more true to a correct flying shape no matter how fast it is going, which will yield better control of the drone. But if and when you crash, it is more likely to break, meaning a rising cost in supplies starting out. A rigid prop is also an issue if it doesn't break or bend when it crashes. A prop is attached directly to the motor. If it hits the ground spinning and doesn't break, that force will go somewhere, off into the motor, which means instead of a $1 to $2 prop change, you might be looking at a $10 to $30 motor change. A prop that is very flexible, however, will not hold its shape as well in high speed or severe changes in direction. But if it crashes, it will most likely just bend the prop and take most of the impact, saving your motor, frame, and other components. Usually you can bend it back into place and keep flying. Temperature can also affect a prop's performance. If it is very cold, flexible props like ones made with polycarbonate are more likely to become brittle and could shatter should they hit something. In very hot temperatures, they will become soft and not hold their form. In these cases, you will want a prop that won't have these issues, such as one built from carbon fiber. For most cases though, a prop built from polycarbonate will give you the best results. A thing to remember when learning and looking into props is that no matter what you pick, you're going to compromise somewhere. Every option for size, shape, configuration, or material is going to have different pros and cons than a different option. Sadly, there isn't a perfect prop for any drone. You just need one that does the best job for what you need. And that covers what props are and why they are important. Once again, please do not ignore the importance of having the right props. It is one of the most important aspects of flying your drone and can have a large impact on how your drone operates, as we saw in this video. If you guys have any questions, definitely let me know, and have fun flying.